Hey, welcome to today's video. So today we're going to be looking at index sublaws. You need to watch the video on index laws first before you come to this one. These are special case index laws. Okay, so index sublaws. Alright, so the first one, number one, is negative powers. Negative powers. Now the thing with negative powers is all that it does is it takes the power to the other side of the divide line. Now I like to say it like that rather than saying it makes it a fraction or reciprocates it. Well, the reciprocated one is better, but a lot of people by the time you get to this, you haven't done reciprocals yet. Some people haven't. Okay, some people have. Okay, so let's take a look at what this means in a general form. So in a general form, if I've got a to the minus n, all that is remember there's the invisible, any whole number I can put over invisible divided by 1. So a to the minus n, I can flip to the other side, it becomes 1 over a to the n. That minus moves it. Doesn't make the thing negative. Careful, a lot of people think that it makes it negative. It doesn't. It moves it to the other side of the divide line. And now, obviously it works the other way as well. If I've got 1 over a to the minus n, there's the minus, I want to get rid of it. It moves it to the other side of the divide line, it becomes a to the n. If you want, you can put over the invisible divide by 1. Okay, so this negative moves it to the other side of the divide line, or moves it to the other side of the divide line. That's the way I like to think about it. So, let's look at an example. The first example, I'm going to do 2 to the negative 3. Okay, e.g. 2 to the power of negative 3. And they say simplify this. Right, so there are two things. In my mind, I like to think of this as two things happening to 2. The first thing that's happening is I've got a negative power. The second thing that's happening is that I'm cubing it. Okay. Start to think of the powers as bits of things that are happening to your base. Okay. So, the negative first. Flip to the other side of the divide line, 2 to the power of 3. Now I've used it up, so it's gone. It's like a power up in the video game. When I use it up, it goes. Now I can simplify 2 to the power of 3 as 1 over 8. 2 cubed is 8. Okay, 2 to the power of negative 3 is 1 over 8. So let's try another one. 1 over 3 squared. Alright, well, e.g. 1 over negative 3 squared. 1 over 3, not negative 3, 3 to the negative 2. I'll get there in the end. Right. Right, now that negative is going to move him to the other side of the divide line. So it becomes 3 to the power of 2. Look, negative, no negative. I've moved it. It's gone. If you want, the invisible divide line is still there, if you want. Okay? Now I'm going to square it. 3 squared is 9. Okay? So 1 over 3 to the negative 2 is equal to 9. Notice, please notice, this negative 2, this negative here, has got nothing to do with the sign of the thing. Look, positive 9, positive a third to the negative 2. Alright. Positive 2 to the negative 3, positive 1/8. Does not change the sign of the number. Okay? It just changes its position, above or below the divide line. Be careful about that. A lot of people make the mistake and call this negative 9. Okay, so nothing to do with the sign. Alright, for now. Okay, so let's look at the index sublaw 2. And I'm going to flip this. I'm getting better at this. Index sublaw 2. So number 2, and number 2 are roots of fractional powers. Roots are fractional powers. Right, roots are fractional powers, and fractional powers are just roots. You know square root of 25? 5? Yeah, you got it. Okay, so how do I write this? Let's go a to the power, a to the nth root, right? A to the nth root, cube root, fourth root, fifth root, sixth root, whatever, is a to the power of 1 over n. Fractional powers. Okay? Roots are just fractional powers. Fractional powers are roots. Remember, equals goes both ways. It's equals. Okay? So, let's look at an example. 4, e.g., the square root of 4 to the power of a half. Well, 4 to the power of a half. Well, a half is, I could write it like this. The second root of 4. But the second root of 4, well, we know what that is. Where's my eraser? The second root of 4 is square root. Okay, we don't bother writing in that little 2 because you can't have a first root. So the square root of 4. Square root of 4, piece of cake, square root of 4, we should know that, is 2. When you get more advanced, it's plus or minus 2. But for now, it's 2. Alrighty. Okay, the next one, the third root of 27. So, e.g., 27 to the power of 1/3. Well, what is this? This is just the cube root of 27. So what times itself 3 times gives me 27? 3 times 3 times 3. So the cube root of 27 is 3. Okay. Now, when you get good at this, you start leaving out this part. You don't bother writing this. You go cube root of 27 to the power of 3. Okay. All right. And last little law, the easier one. Anything to the power of 0 is 1. Anything to power 0 equals 1. Okay? So what is that? That's just a to the power of 0 equals 1. I don't care what a is. I couldn't care less. 957, e.g. 957 to the power of 0. 957 to the power of 0. Oh, 1. D to the power of 0. D to the power of 0, 1. Okay, piece of cake, huh? Anything to the power of 0 is 1. Okay. So, let's just look at how to use this. I'm going to come onto this page because I'm going to just rub stuff out and make some space. And we're going to look at how to use this. Okay. So, e.g., let's put this into some hard examples. 4 to the power of 3 over 2. 4 to the power of 3 over 2. Right, now, here's the way I like to think about this. This is 4 to the power of 3 times a half. 3 halves. 3 over 2. 3 times a half. Now, multiplication is commutative, so you could do this. 4 to the power of a half times a 3. You with me? Now, from law 3, when I raise a power to a further power, I multiply powers. So this I could write as, this is really long-winded, but I'm getting there. 4 to the power of a half raised to the power of 3. Or 4 to the power of a half, that's just the square root of 4 raised to the power of 3. The square root of 4, are you still with me? Sorry, because this is quite long-winded. The square root of 4 is 2, raised to the power of 3, 2 to the power of 3 is 8. I think it's very useful to split any powers, especially fractional powers, into numerator times the fraction. Alright, and decide which one is useful to get rid of first. Normally, 9 out of 10 times, you want to get rid of the fraction part first. So I want to do the root part first before I go up into the powers. 9 out of 10 times. Sometimes it'll be better to get rid of the numerator part first. So I'd raise this to the power of 3. But 4 to the power of 3 is 64. Those of you who know it. Square root of 64, 8. So the order doesn't really matter. Okay, let's do one more. 8 to the power of 2 divided by 8 to the negative 3. Oh, this one's fun. So, e.g., 8 to the power of 2 divided by 8 to the negative 3. Now, watch what's going to happen here. When I divide powers, I subtract exponents. A to the 2 minus negative 3. I'm going to do this 2 different ways. A negative and a negative is a positive, so it's a to the 2 plus 3, which is a to the 5. You with me? I could do it that way. Or I could use law, the index sub law 1 first and make the negative into a positive. I could also do it this way. I could write this as a to the 2 times by, bring them to the top, a to the 3. The negative goes. Do you see? And I've moved them above the divide line. Okay? When I multiply powers, I add exponents, which equals a to the 2 plus 3, which equals bada bing. Okay. These are very manipulative. These are very malleable, so you can change them, you can move them, you can get used to them. You can do things in different orders. One person's way of getting to the end is not the same as the person sitting next to them. Okay, so get used to this. Try this. There's some more examples on my notes. Go look for some more from your teacher. Go look for some more in the book. Okay, go check out some more on the blog. More videos. You know what I'm saying. Okay, but just remember, I'm here for you.